Twitch stream. Today is Valentine's Day, February 14th, 2019. So those of you who are tuning in hopefully know what you've gotten yourself into. I am working on a talk about reference capabilities in Pony, and so I'm putting together some slides. And so the way I usually do that is I kind of like going with hand-drawn slides. So I'll just kind of be working on that and maybe talking my way through it. And if anybody has any questions for me, feel free to ask some questions. Otherwise, like I said, I'll just kind of work here and see what I can do. I have an incredibly precarious camera setup right now, so I don't know what the best way to do this is. I can maybe move things over here like this, and anyway, so yeah, I told some friends over at Movable Ink that I would talk about Pony for them, and so I figured I'd focus on talking about reference capabilities, since those seem to be one of the more interesting things that you can talk about. Seem to be having some network issues here. I'm gonna restart this real quick. Okay, hey, welcome back. So it turns out that if you connect to the Wi-Fi router that's close to your office, rather than the one that's downstairs, you get significantly better connections. So, hey, lesson learned. Anyway, yeah, so basically, my plan for the talk is to start with kind of a what is Pony, and then talk a little bit about actors and classes and objects. So I think in order to understand what's going on with Pony, in order to understand some of the things I'm going to present, you kind of need to understand what it means if I talk about an object. And you definitely need to understand actors. And you kind of need to understand objects. So talk a little bit about those things. And then talk a bit about messages that are passed between objects. And somewhere in here, maybe also talk about concurrency in and of itself. And then once I've explained those things, then I'll kind of dive into reference capabilities, or ref caps. And so I'll start off by talking about basically the three types of access that you can have to an object. So there's sending messages, there's reading, and there's writing. And then there's, so I guess, yeah, three types of access. And so then from there, talk about the read-write rules. And then once I've done that, this is where I actually want to start introducing reference capabilities. So from there, we'll go into ref caps. And so my thinking for this talk, I've done a few Pony talks and I've talked about reference capabilities in a few different ways. For this talk, I think I'm going to try an approach where I start off by talking about ref and val. And the reason I want to do that is that I think those two are pretty easy for most people, I think, to understand. Ref basically means you can read, there can be any number of other references that read and write to an object. And val means that all of the references to all of the other references to the object and this reference can not be used to write. So they're read only, or read and send only. And so when you have these two things, you can start to look at, you can start to understand how message passing works and why, if you're following the read-write rules, you can send a val to another actor, but you can't send a ref to another actor. So, and the reason for that, just for those of you who are watching this to learn about Pony, the reason for that is that the read-write rules, I think I even have a card here. I'll just throw this up real quick. So the read-write rules say that if an object can be read by multiple actors, then it cannot be written to by any actor. And if an object can be written to by an actor, then it cannot be read or written to by any other actor. And so if you've done any like concurrent programming or anything like that, this maybe makes a little bit of sense. Basically, you can't have two actors that can both write to an object. So I think maybe there's something that I want to add somewhere in here. I think when I'm talking about Pony, I need to make sure that I talk about how it's data race free. And there are no locks. Those are two of the important things that I think people need to know about. So in other languages, you can have more than one reference that can, in more than one thread that can be used to write to an object. And when you have that happen, you have the potential to have a race condition. And so usually what you'll do is you'll use a lock of some kind to ensure that only one thread at a time can write to the object. And Pony's way of dealing with concurrency using reference capabilities doesn't use locks. So it's kind of important to make sure that people are clear on that. So anyway, explain why we can send vals. So we can send vals to other actors because that doesn't violate these rules. If an object can be read by multiple actors, then it cannot be written to by any actor. So since val is read-only, you should be able to create another reference to a val in another actor, and that reference also has to be val, but you won't violate this invariant. And because they're read-only, you don't have to worry about the write rule. So I guess I'll label these. So these are our rules. Okay, so once I've explained ref and val, I'm trying to decide what order I want to do this in. I think the next thing to do is maybe to explain box, because box is a reference capability that you can use for a reference to either a val or a ref. It's the particular reference that's box will be read-only, but there may or may not be other references that can write to this thing. So we can't send a box because we aren't guaranteed that there aren't other actors that can write to it. But we can have a val or we can have a ref, and we can treat it in read-only fashion. And so that way we don't have to have different kinds, different functions, one that takes a val argument and one that takes a ref argument. So let's see here. Then I want to talk about tag and talk about the fact that if you have a tag reference to something, you can basically do an identity comparison to another object. And if that tag reference is a reference to an actor, then you can send that actor messages. In fact, you can use all of these reference capabilities to send messages to actors. And so there's a part of me that wonders if maybe I should move tag up and actually just talk about that first and say here's what you can do with tag, and you can do this with every one of the reference capabilities, but the only thing tag really lets you do in terms of access is it lets you send a message to an actor. So once I've explained these things, then what I want to do is talk about the idea of, so I want to talk about ISOs, and I think the way to do that is to introduce the idea of consuming a reference. Although actually, yeah, I'm still not sure how exactly I'm going to do this, but the idea with an ISO is that you only have one reference that can read and write to an object, and that reference has a reference capability of ISO, or isolated. And so this is kind of like, if you're familiar with linear types, it's similar to that. The idea is that you only have one reference to the object, and so you know that if you get rid of that reference, there are no other references to that object that can read or write to the object. And so when you get rid of this reference, you can create a new reference that's assigned to the object with basically whatever reference capability you want, because there are no longer any restrictions on what you can and can't do with that object. So somewhere along here, I want to talk about ISO and consume. I'm still working out what order I want to do that. And then finally, I can talk about transitional. And what transitional means is that you have you have the transitional reference is able to read and write to the object, but there are no other references. There are not allowed to be any other references that can write to the object. So you could have some other box references, but the transitional one is the only one that you can use to write. And the useful thing about this is that you can you can take a transitional reference. So for example, you could create some sort of initial object, and then you could start modifying it and making changes to it. And then when you consume the reference to that transitional object, you can then turn it into, for example, a val or something like that, because you know that you've gotten rid of the only writable reference to the object. And so it's kind of like ISO, but not quite as restrictive, in the sense that, again, there could still be readable references floating around out there, but you're guaranteed that there are no more writable ones. And so, let's see here. So I think up here in what is Pony, I think another important thing to talk about is local reasoning. So one of the things that Pony, or one of the things that reference capabilities take advantage of, is this fact that by just looking at the guarantees that are made about a particular reference, you can understand those guarantees relate to the other references to this object. So again, for example, if you have a val, you not only know that this particular reference is read-only, you also know that all of the other references to this object are read-only or tag, meaning that they can't read or write. And so in that way, you can actually make guarantees about what sorts of things will be able to be done with a reference just by looking, or with an object, just by looking at a single reference to that object. So I think it's important maybe to point that out up here at the beginning of the talk, and then maybe come back down here and just talk a little bit more about it once I've introduced the reference capabilities. And maybe say local reasoning part 2, where I just kind of emphasize the local reasoning aspect of this. Yeah. And so I think after I've done that, I might try to maybe show a few examples. The quintessential example, I think, is some sort of counter that's shared among actors, and show at least one or two ways that we might create a counter that can be incremented by different actors that avoids the race conditions that you might have if you had threads in shared state. So I could show some code for something like that. So let's see here. So I have some things. Let's see what I've got so far. Let's see how well I'm doing. So what is Pony? So the Pony compiler gives you compile time guarantees that your program is data race free. Maybe so let's see, that's the data race free part. Pony does not use locks to manage concurrency. So maybe we just call this data races. And then we can say something like local reasoning. Oh, I wanted to, since that's data race free, I was gonna cross that lock out. I've got this nice brush pen here. I can do something cool like that. Very, very bold and bright. So Pony uses local reasoning about reference capabilities. To determine if objects can be referenced by more than one actor. It seems like a reasonable start here. All right, so anyway, then I want to talk about actors and classes and objects. So I don't know if this is the best way to talk about it, but basically I want to convey that there are actors and there are classes. You can have an instance of an actor, you can have an instance of a class. Usually we talk about both of them as being objects. So when we say object, we could be talking about an actor instance or a class instance. Actor instances can have behaviors, functions, and properties. Class instances can have functions and properties, but they can't have behaviors. Actually, this part here is really messages and behaviors. Okay, and so talk a little bit about actors. Actors receive messages, and they process messages one at a time in the order in which they were received. Different actors can be processing messages at the same time. So an actor sends a message out, the receiving actor puts it in its queue, and then goes through and processes one message at a time. So behaviors process messages asynchronously. Everything that happens in a program happens in some actor's behavior. So even at the very beginning, when a program starts up, the Pony runtime creates a main actor and then runs that actor's create method and create behavior. And so that's the thing that kicks everything off. And you don't have any asynchronous behavior unless you create new actors and send messages to them. And so again, at most, one behavior is active for a given actor instance. So that kind of talks about messages and behaviors, and maybe talks a little bit about concurrency. I don't know, that may be enough. That maybe I should do more. I'll think about that. So I think the next step is to just say, hey, now we're going to talk about reference capabilities. So let's make this big and bold so people know that we're doing something new. So let's see here. Reference capabilities. Reference capabilities are guarantees that are made about references that can be used to reason about other references to the same object. So over here we've got a reference that has some sort of reference capability R, and it refers to an object, and in theory there can be lots of other references over here. We can look at this reference capability R and know some things about these other references, and that knowledge can then be used to help us figure out if it's safe to pass this object off to another actor. Every reference has a reference capability, so there's no such thing as a reference without a reference capability. You may not explicitly specify it, but it's always there. Hey, so I've got a note. Hey, maybe when discussing objects, you could state that message passing in Pony is very similar to calling a method, and the difference is in method definition keyword, but actor and class are still objects. This guy who was streaming his first time with Pony had a hard time grasping how messages get sent, since it should be all about actors. Yeah, maybe I'll... let's see here. Maybe I'll add a detail about that. Yeah, and I don't have any code samples in here just yet, but I've been thinking about if I want to add them, and if so, how I want to do that. So maybe that would be a good place to just show a little bit of, you know, some actual real-world Pony. Yeah, what Major Code said. Maybe a short example slide would cover it. Let me think about that. Okay, then I have this access level slide, which I think I need to redo, but basically this goes over the different types of access. You've got send a message, which any reference can be used to send a message regardless of the reference capability. Then there's read, which means that object properties can be read either directly or in a function. And write means that object properties can be modified, again, either directly or in a function. So that's what we mean when we talk about read and write access. And then here's our read and write rules. Again, if an object can be read by multiple actors, then it cannot be written to by any actor. That's the read rule. And if an object can be written to by an actor, then it cannot be read or written to by any other actor. So those are kind of the two sets of restrictions that we have. And again, an easy way to think of it is Pony doesn't allow you to have more than one actor that has write access to an object. And if any actor does have write access to an object, that means that no other actor can have read or write access to it. So let's see here. So I kind of came up with these little slides. I'm not sure how great they are, but anyway, the idea is that we've got a reference over here, and it refers to an object, and then there's all the other potential references out in the program. So if we have a tag reference, we can use that to send messages to the object. But we can't use it to read, and we can't use it to write. And so what we know on the other side, just by knowing that this thing is tag, what we know is that there could be some other references that could send, there could be other references out there that can read, and there could be other references out there that can write. So with a tag, we really don't have a whole lot to reason about these other references. Basically, at that point, they could be anything. But we do know that we can use the tag to send messages, which is still useful. So then we've got val. And val, again, we can send to an actor. We can use the val reference to read values in an object. But we can't use a val to write values to an object. And so what we know about all the other actors is that there could be other ones, could be other references that can send messages. So again, we've talked about that. Basically, any reference, even a tag, can be used to send messages. There could be other references that can read from the object, but there can't be any other references that can write to the object. So a val basically says this object is globally read-only. And so the nice thing about a val is that we can take a val reference and we can use that to create another val reference that we can then that another actor can use. So we can use this val to pass a reference off to another actor that other actor can use. But again, that other actor will only be able to create a readable reference to that object. So you're sharing the object, but you're sharing a read-only object. And this is similar to what a number of languages do. For example, Erlang does this. You pass actors around, or sorry, you pass things around, but they're read-only. And so you can't modify them, because otherwise you could potentially have two actors trying to modify something at the same time, at which point you'd have a race condition. The next reference capability is ref. And I don't know if there's any value really in putting ref before val or val before ref. So that's something that I'm thinking about. But anyway, so if you have a ref reference capability, then you can send to an actor, if you have a ref reference to it. You can use the reference to read the object, read values in the object, and you can use the reference to write, to modify the object. What you know about the other references out in the world are that there could be some that can send to the object. Again, any reference can be used to send. You could have another reference that can write to the object, other references that could write to the object, and you could have other references that could read from the object. Now, if you remember, we had those read and write rules. Basically what this means is that you could have more than one reference that can write to the object. Now, that doesn't necessarily mean that you do, but it means that it's possible. And since Pony only uses local reasoning, it doesn't look to see what actually exists out there. It just says, okay, it's possible to have another reference that can write to this thing. Therefore, we can't create a new reference to this and send it off to another actor, because there could potentially then be multiple actors that would have writable references to this thing, at which point we could get a race condition. So I've got a question here. You made me curious. Can I have a class instance that is a tag and call a fun tag on it? Why would I do so? You could have a class instance that's a tag. You could call a fun tag on it. You probably wouldn't do that with a class because you wouldn't have access to any of the internals. You wouldn't be able to read or write any of the properties in the class. You could do something like that as kind of a, almost like a static function or something like that. You do occasionally, though, see a pattern like that on actors. And this is probably, maybe this already made sense, but in some cases you might want to, for logging or for debugging or things like that, it might be useful to call a tag function that then calls the behavior. So basically it encapsulates a behavior. And that would let you do things like, again, stick some logging in or stick some debugging in that you then know will happen synchronously with the call, so that you know that the thing will happen eventually. And then that function will then make a call to the, will make an asynchronous call to the behavior. So again, you probably, I can't think of any reason that you would do that with a class, but I have seen, we've done it at Wallaroo with actors. Okay, so then the next thing I have here on my list is explain why we can send vals and not refs. So I kind of already did that here. I don't know that I necessarily need another slide on that, but I don't necessarily know that I don't need another slide on it either. So I'll think about whether to add a little more detail about that. Okay, and then the next reference capability that we have is box. And so if we have a box reference, again, if it's a reference to an actor, we could send the actor a message. We can read properties of the object that we're pointing to, but we can't write, so we can't modify the object. And on the other side, in terms of what we know about the rest of the world, there could be other references out there that can send to an actor, if this thing is an actor. There could be other references that can read properties of this object, and there could be other references that can be used to modify this object. So in a way, it's kind of, you might look at it and say, well, this is kind of like a val. But what it lets you do is it lets you write functions that could take either a val or a ref as arguments. And you could just say it's a box, and then you'd have a read-only reference to that thing, but you wouldn't have to make the same strong guarantees. So you can't reason as strongly about the other actors that are outside, but you can at least have something where you can make this reference point to either a val or a ref, and that makes it a little easier to write to write functions, as long as those functions only need to be able to read the objects. If you need to write, then you basically have to pass a ref or an ISO or turn, is what we'll talk about in a minute. But if you just need to read, then you can use a box. So the place where this, I think, really starts to kind of get interesting, and where Pony starts to kind of break away from a lot of other languages out there, is the ISO reference capability. And what ISO means is that this is the only reference that can be used to read and write to the object. There can be other references out there, but they can't read and they can't write. They can only send. So basically, if you have an ISO reference, you know that the only other references out in the world are tag references, if there are any. So this becomes useful because you can have an ISO, and you can take your ISO and you can modify it, and then you can convert it into something else, or you can hand it off. And so basically the idea is, what if you had an object but one less reference? So if you had a reference to an object and then you were able to get rid of that reference, what could you then say about the object? And so the way you get rid of a reference in Pony, at least the way that I'm going to talk about right now, is using the consume keyword. And what consume does is it says, okay, this reference that you had, this named reference, it's going away. You won't be able to use it anywhere else in your code, and so we've gotten rid of it. So that in and of itself isn't necessarily super useful, but what you can do is you can use consume on the right side of an assignment and assign the resulting object to a new variable, or to a new reference. And the new reference now gets reference capabilities based on that local reasoning that we were able to do. So yeah, so before, if we had this object foo, oh, sorry, and we consumed foo and assigned to bar, what could we do knowing something about foo to then know something about bar? So, for example, if foo was an ISO, and this is where I think I may need to like make some example cards. So, consuming an ISO. So if we have foo here, and we get rid of foo's reference, remember, we know that since foo was ISO, we know that these other potential references out in the universe could only send messages to the object. So they can send, but they cannot read, and they cannot write. So now this new thing, bar, since we know that there's no other readable or writable references out there, we could make it an ISO, because we know that it would still be that bar would still be the only readable, writable reference to the object. We could make it a transitional, because transitional only transitional says that there could be another readable reference out there. We could make it a ref, because we don't have to worry that there's any vowels out there that would prevent us from making a ref. We could make it a vowel, because we know that there's nothing else. Since we know that there's nothing else out there that can read or write, we can safely say, okay, this is now a vowel, and now everything else that points to this thing has to be read-only. We could make it a box if we wanted to, and we could make it a tag. So basically, if you consume an ISO, you now have kind of this naked object, if you will, this object that doesn't have any, it's not really encumbered by any restrictions from any other reference capabilities. And so you can basically make this, give this new reference whatever reference capability you want. So again, this is kind of nice, because now you can, bar could be an argument to a message, which means that this object could now be shipped off to another actor. And so now this other actor would get an ISO, and now it's got a readable and writable reference to this object. And so this is, again, kind of what starts to separate Pony from a language like Erlang, where you can only pass around immutable values. What this means is that you now have a way to tell the program, hey, I'm going to pass this writable reference to something off to another object, or off to another actor, and I'm going to do it by getting rid of the only reference that I currently have that's readable or writable. And so suddenly you've got this way to not just be able to pass data around, but to be able to pass mutable data around and be able to do it in a safe way. So because of this, we never end up violating those read and write rules. So we never have to worry about a race condition. We've always got a safe way of passing this thing around. So let's see here. I feel like ISO is really the biggest, the most interesting topic of a consume to talk about, because and if you go and you look at the documentation for Pony, basically, if you consume a ref, because there could still be other ref references to the object, you really don't gain anything. You can't do anything new. Basically, you can just create a new ref. Same thing with a val. Because you could have other val references to the object, you can't really make any other guarantees, and so the only thing that you can do is basically create a new val. If you remember with transitionals, because they only have one, because the transitional says there may be other readable references to this object, but I am the only writable reference. If you consume a transitional, it's kind of like consuming an ISO, but you're a little more restricted because because there still could be readable references out there. So you can create a val, but you can't, or yeah, but you can't like create an ISO from a turn. And a tag, if you consume a tag, that doesn't really do anything for you. So I guess that's kind of the local reasoning part too that I had wanted to talk about. I guess, yeah, the important things, and maybe I can make a slide around this, but the important things that I wanted to emphasize are that by looking at the reference capability for a particular reference, you can reason locally about the global state of your program. And when I say you, really what I mean is the Pony compiler can reason locally about the global state of the program. And so that's how, at runtime, it can guarantee that your program is data race free, because it can guarantee that you are doing the right things with reference capabilities to ensure that the read and the write rules are being followed. And if they're not, then you'll get a compiler error, and it won't let you compile the program. So this is also a little different than a language or a runtime or something that has some sort of runtime enforcement, or tries to at runtime enforce something like this. These aren't runtime checks. These are compile time checks. And again, they're done by looking at what the reference capability is for a reference and saying, okay, what can I do with this reference in terms of using the object that it points to from another reference. So consume and consuming an ISO. So those are kind of what I've got. My thought had been to maybe have a slide. Let's see here. Hang on. Can I do this? Yeah, so my thinking had been to maybe create some sort of actor counter program this gets a little tricky, but let's see what we can do here. So we've got a counter, and it just has a property, that's var. So we want to just have this thing store a count that can be incremented. There's nothing we really want to do here. We want to have a behavior that increments, and let's even make it so that we can pass a value if we want. The default value is 1, so we can say x equals, yeah, just increment. And then let's see here. Let's see, we want to have an actor called incrementer that gets the counter. So let's see. Sorry, I've got a comment here. I'd like to see examples of how variables are created in one actor and later passed to another. Do you have to make sure that the object you're passing is created with certain reference capabilities? And would other ref caps stop you from passing data to another actor? So yeah, basically, so Pony actually has this idea built in of certain reference capabilities being what it calls sendable. And so that means that if you have a reference with one of the sendable reference capabilities to an object, there are ways to send that object off to another actor. And so val is sendable because you can consume a val you can take a val and you can just pass that off to another actor, and that's safe to do because no actor can modify it. ISO is also sendable, and that's because if you consume the ISO, you can pass it off to another actor, and the other actor will receive it as an ISO. And tag is sendable because since you can't read or write a tag, you can safely pass that tag off, and the other actor will then just get a tag. So there, we talked a little bit about the fact that, like, if you consume an ISO, there's a bunch of different things. There's a bunch of different reference capabilities that the new reference could have. And I guess on the other end of the spectrum, like, if you pass a tag, the only reference capability, the only thing you can do with a tag is create a new tag. You can't create any new kind of reference from a tag reference. So you're constrained in that sense, and the compiler will enforce that. So if you have a tag and you try to pass it in a message where one of the message parameters is an ISO, it will tell you can't use a tag where it expects an ISO. And so in that way, yeah, you have to make sure that the reference that you're passing has the proper reference capabilities to be passed from one actor to another. And again, I think an important point to keep in mind is that the reference capabilities are not really properties of the object itself. They're properties of the reference. And so you don't really have, you don't really have like a tag object. You have a tag reference to an object. And so you could have a tag reference to an object and also somewhere else have a reference to the object. Yeah. Yeah, so I'm thinking through this counter example. This may actually not be a great example because what I was going to do is have a bunch of incrementers that are incrementing the counter and then show that there was never a data race. The thing is, I think what that demonstrates is less what's going on with reference capabilities and more how you can basically use actors to ensure that you have synchronous access to data object. In our case, the this underscore x variable, because increment would only ever be run by the counter actor. You never have to worry about a race condition. So I think I'm going to spend a little more time thinking about a better example there that maybe more clearly illustrates what we're thinking in terms of reference capabilities. So it's 4 o'clock. I need to go. Thank you, everybody, for tuning in. I will, since I had technical difficulties earlier, I guess I'll splice the 2 videos together and put them back up here. And yeah, thanks for tuning in. Thanks for giving some feedback. Hopefully this is useful to people. And take care. Have a good day. Bye.